Okay, real quick lesson on, let's see, inequalities, graphs, and interval notation. So if you start with an inequality, you want to put the important numbers on a number line, aka the graph, first. You want to shade the correct direction, that's either going to be left or right. You want to use an appropriate parenthesis or square bracket based on what sign we're using. You can see that information up here. And then you want to write the interval. So really quickly, I'm going to do a few of these here. Let's say I'm going to do example 1, 3, and 5. And you can see we have an inequality here. X is less than or equal to 7. So I have a graph here. I want to put the important number there. And since it is a less than or equal to, I know less than means numbers that are to the left. So we do a little shading like this, or this is how I shade anyway. Then I need to figure out, I need to take a look at this symbol right here. That is an less than or equal to, and we have this split of information up here, something like this. If there is an equal to, you can see here, if there's an equal to underneath an inequality sign, we will use square brackets. So I need to shade left, and since there's an equal to, I'm going to put a square bracket here at 7. In the interval notation over here, from the graph, sorry, that's the end of the graph. The interval notation over here, we need some sort of start and end. And you can see here, we're always going least to greatest. And for the current exercises I'm working through, we can consider this left to right. So there has to be a start and an end, and we're going to separate it like this example up here with a comma, and then we have to have the correct grouping symbols around it. So here we have a 7, and we have this square bracket around it, as you can see right here on the graph. But on the other side, we shaded left forever. And on every single one of these graphs, left forever is negative infinity because the negative numbers are to the left. And right forever is positive infinity because that's where the positive numbers are. So we need a starting point. We have our ending point here at 7. Our starting point would be negative infinity. And infinity always gets parentheses around it. So you can try example 2, you can try example 4, and you can try example 6 at the end of this, and you should be able to do it. So let me get through example 3 and 5 so you have an idea what's going on there. Again, we want to put the important numbers on the graph. So I've got a -2 and I have a 5. And this time you can see the variable is between them, so I'm going to shade in between. So now I need either parentheses or brackets, and you can see here with the less than and the less than, up here at the top, no equal to means we will use parentheses. So I have a parentheses here and parentheses here. And now the interval becomes very easy. It just kind of falls right into place. You have a -2 to 5 with parentheses on both sides. Now you can already see from this first example, we don't have to have a square bracket on both sides. We can have some sort of mixture. It was just kind of nice that we had both parentheses here. But for this last one, we're going to do something very similar. So I've got that -4, I've got that 1 over here. And again, the variable is between them, so we will shade in between them. And this time, we will use square brackets on the 1 and a parenthesis on the -4. So we have a starting point at -4, we have an ending point at 1 with these symbols here. Now going the other direction, I'm only going to do here, let's see, example 8, 10, and 11. So that's this one, and this one. There we go. So going backward into inequality notation from interval notation, it's always good to have a graph drawn again. So we're going to follow the same thing we did up here, just go backwards. So we started with an interval. We already know what the what grouping symbols are around it. So we will put the important numbers on the line in shade. Oops. -5, parenthesis 2. And we shade in between there. But to get back into inequality notation, we have to have a variable. And since we are shading between these two numbers, we will surround the variable with these inequality signs. And yes, they will be pointing the same direction. We have a less than, less than. Now this is where we have to be careful with putting the inequality symbols here. Before we had to worry about the inequality symbols and what symbols that gave us on the graph in interval. Well, now going backward, we have to worry about the interval symbols to tell us what's on the graph in the inequality. So a parenthesis means we will have no equal to, and a square bracket means we will have an equal to. So we will put that equal to right here. And this one will not have an equal to, this right inequality. And so again, x is between these two numbers. When we graphed this here, it is shaded in between them, so x is between these two numbers. There's a square bracket on the -5, so there's an equal to here between the x and -5. This is a parenthesis on the 2, so there's no equal to here between the x and the 2. These last two I think are going to be pretty simple. We have this one that starts at 2 and shades all the way over to infinity. Now when you only have one number, we can only put one number in our inequality over here. But as it turns out, we like to have the variables on the left, as you can see up here. So this graph tells us we want all the numbers to the right of 2. You can see it here as well. Numbers between 2 and infinity. So just to the right. Infinity means arrow up here in the shading. So to the right means greater than. We have a parenthesis here, so we are not looking to use an equal to, and we will just have the number 2. So the inequality notations use no infinities, not positive, not negative. So we just want the actual numbers here. For this last one, it's very similar. We have 3. We know it's got to be shaded left because the negative infinity is where we're starting. We're going to use a square bracket because that's what is given over here in the interval. And that means we will have an equal to for this inequality sign. And left means less than, so we will be x less than or equal to 3. Now with these inequalities down here, I am out of space to work these, so I'm going to try a couple on the next slide. We'll see what happens there. Yeah, these will work. Okay, so for these inequalities up here, we solve inequalities. So I'm actually going to work example 4 out two ways. I'm going to rewrite it over here. Negative 3 times x plus 2 is greater than 2x minus 11. There we go. So this first way I'm going to work it out is to show you what happens with some inequalities, just so you know how to operate with it. So in order to solve a linear inequality, you just do it like a linear equation. So you distribute, you go negative 3x minus 6 is greater than 2x minus 11. Now let's say you're a smart person, you're out there, I know what I'm doing. And you say, I like having a positive number of x's. So I'm going to move the 3x's, the negative 3x's to the right by adding 3x. So that leaves you with a negative 6 is greater than 5x minus 11. And then you just solve it as if this were an equal sign. We keep going. We just treat it like an equal sign. We keep writing greater than, but we treat it like an equal sign. So add 11, add 11. That gives me what? 5 is greater than 5x. Divide by 5, divide by 5. 1 is greater than x. Now I just got done saying on the last slide, we like having the variable on the left. So if you go through and solve an inequality, you end up with a variable on the right, quick. You want to change that. So I'm going to switch this inequality around, but as you can see here, the inequality is, if you will, eating the one. It's trying to eat the one, like the Pac-Man or the alligator that you may have learned long ago. So if we swap an entire inequality around, we have to swap the inequality symbol as well. And then you want to graph this and do the interval. So when you do these, the person who is assigning this work might look for 3 different answers. So that's one way to deal with inequalities, is to move the variable to the left. This, having the variable on the left, just makes more sense out there in the real world. Next, I want to solve the same inequality, but not move the minus 3x to the left. So I'm going to start here. There we go. And I'm going to subtract the 2x to the left side. So if I subtract 2x from both sides, I'm going to have this. Oops. And then I will add 6 to both sides of this inequality and get negative 5x is greater than negative 5. And if I do the next step correctly, I should get the same answer as I got right here. I should get exactly the same answer. So I'm going to divide both sides by negative 5. And I get x is greater than 1. Well, hang on a minute. If I'm doing the exact same problem, I should get the exact same answer. This x is less than 1. This x is greater than 1. This doesn't make any sense. I should be getting x is less than 1. And I will. I mean, I haven't gone over what needs to happen yet, but this answer is not correct. So what's going on here? Why should this turn into x is less than 1? Just like we got over here. Well, there's this extra little rule here that states if you multiply or divide by a negative number in an inequality, the sign changes direction. This sign changes direction. And that's it. But the key word here is negative number. Negative. If you look back over here at this example, between this step and this step, the inequality sign did not change directions. I divided by a positive number. You love dividing by positive numbers out there. Divide by a positive number all day long. It doesn't change the inequality sign. When you divide by a negative, that's when it happens. For this one over here, you have 1 minus x over 2 is greater than 4. And if you have a fraction, you'll just want to multiply by the LCD, which is 2 in this case. So you'll have 2 minus x is greater than 8. Subtract 2 from both sides, negative x is greater than 6. Divide by, negative 1. X is less than 6. And again, you will want to graph this and create an interval, which in this case will look something like negative infinity to 6. The interval over here for this other example will be, what is that? Negative infinity to 1. And you can make the graph accordingly. Now for this last section, while it is sometimes important to understand what's going on with this example 1, it's not as important to understand as this part. So with this example 1, I will not be doing this part, just this part. And this is how most inequalities are presented, like this here, this here. I just want to do 2 of these. I'm going to do example 1 there and example 4 so you can see what happens. And this, again, these inequality symbols are pointing the same direction. To isolate the x in the middle, you'll want to first subtract 3. And this time you're going to do it to all 3 sides, the left side, the right side, and the inside. Because that's how you're going to isolate the x's, manipulating the inside. So that leaves me with a negative 2 is less than or equal to 2x is less than 8. Then you divide everything by 2. You get negative 1 is less than or equal to x is less than 4. And yeah, you'll want to do the graph of this thing. Negative 1 to 4. Square bracket, parenthesis, shade in there. And then your interval would be negative 1 to 4, like this. Now the last example I want to do here is showing you again, these inequality symbols are facing the same exact direction. This example, they're both greater than. In the last example, they were both less than, and that's fine. Either way works as long as they're facing the same direction. So lastly, we have this subtract 6. We have, what is that? Negative 16 is greater than negative 2x is greater than negative 26. The very last thing we need to do here is divide by a negative 2. And so here comes this rule again. This is why I was doing it. Up here we divided by a positive 2. The inequality sign stayed the same. Down here we're dividing by a negative 2, so these inequality signs are going to change direction again. X, 8, 13. And then yes, you can graph this again. And you can put it in interval notation. I hope that is a pretty good crash course on how inequalities work, linear inequalities, interval notation, graphing, all of it.